kind of backed up to a previous slide where we did some long division. And from there, today, we're going to look at what's known as synthetic division. So let's just analyze what we have here for a few minutes. We said that when we divided by x minus 2, we got an answer of x squared plus x minus 3. Therefore, from the way we check an arithmetic, we said that our divisor x minus 2 times our quotient would give us back our original dividend or polynomial here. So we notice that x minus 2 is a factor of our polynomial. Now what if I wanted to let that polynomial equal 0 and find where it was 0? Well, then this factored form is really going to help me, isn't it? And as I have a factor here, I'll set it equal to 0 and get x equals 2. Now what I want you to notice is if we have a factor of x minus 2, then x equals 2. So if I wanted to do synthetic division with this, I would not use negative 2, but 2. And you say, what on earth are you talking about? Well, I'm fixing to show you. So we know our answer here. Let's erase what we have here. I'm going to show you something really, really neat. Just wanted to show you why I'm going to run through 2 instead of negative 2 with that. I'm going to take the coefficient of x cubed, the coefficient of x squared, the coefficient of x, and then our constant, and I'm going to run through a 2 because remember when I set it equal to 0, x minus 2 equals 0 gave us x equals 2. So I run through what x equals rather than the minus 2 in the factor. Bring down the 1. 2 times 1 is 2. Add. 2 minus 1 is 1. 2 times 1 is 2. Add. We get negative 3. 2 times negative 3 is negative 6. Add, and I get 0. That 0 is actually our remainder, and this says x squared plus x minus 3 is our quotient. Isn't that what we got here? X squared plus x minus 3. Isn't that neat? That is a shortcut for long division called synthetic division that somebody noticed a pattern and they set it up, the algorithm or the way to do it, so that we could add instead of subtract and be more accurate that way. So that's a real interesting thing. Now let's go and actually work a problem using synthetic division. Okay, first of all, we're going to look to see if we need a 0 placeholder, just like we did with long division. So we have an x squared and then an x to the first term and then no x's. No, we're not missing a power. So now we'll write down the coefficients, the coefficient of x squared, the coefficient of x, and the constant, and then we'll run through a negative 3. Remember, we don't run through the plus 3 when we have x plus 3. We want to run through the negative 3. Bring down the 4. Negative 3 times 4 is negative 12. Negative 9 plus negative 12 is negative 21. Then negative 3 times negative 21 is positive 63. I add, and I have 63 minus 7 is 56. So what's my answer? 4 to 1 less power than our lead term, so we have 4x, then a minus 21, and then we have this 56. It's obviously the remainder because there's nowhere else to put it. Plus 56 divided by x plus 3. Remember, a few minutes ago, we didn't have a remainder except for 0, of course, and when we saw that 0 remainder, we knew that we had factors. So that's my answer. Isn't that a lot quicker? Well, let's do another one. Check and see if I'm missing a power. Fifth, oops, I'm missing one right here. Let's tell ourselves that we have 0x to the 4th. x cubed, x squared, x, no x's. So we need one 0 placeholder. So 6, 0, minus 8, minus 5, minus 3, and 1. And we're going to run through a positive 2. Bring down my 6. 6 times 2 is 12. Add 12 and 0 and get 12. 2 times 12 is 24. 24 minus 8 is 16. 2 times 16 is 32. 32 minus 5 is 27. 2 times 27 is 54. And 54 minus 31, no, that's a 3, isn't it? I'm sorry. Let me erase that. That 54 goes under my minus 3. So 54 minus 3 gives me 51. Then 2 times 51 is 102. And now my remainder is 103. All right, what do I have? 6 to 1 less power, so it must be 6x to the 4th. And then plus 12x cubed plus 16x squared plus 27x plus 5 plus my remainder of 103 over my divisor of x minus 2 is my answer. You might like to ask me if I could ever have a 0 placeholder in my answer. Sure. I could have a 6x, a 5x, or a 0x. And of course then I wouldn't write the x term in my answer. All right, let's move to another problem. One more time with synthetic division and placeholders. We are missing an x to the 6th and 5th. That's a little too much to squeeze in there, so let's just look at it as we go. 1x to the 7th, no x to the 6th, no x to the 5th, 1x to the 4th, minus 9x cubed, no x squares, no x. I'm going to put that 12 way over so I won't think that it's something that it's not. And I'm going to run through a negative 2, so bring down the 1. Negative 2 times 1 is negative 2, add. Negative 2 times negative 2 is 4, add. 0 and 4 is 4. 4 times negative 2 is negative 8. Negative 8 plus 1 is negative 7. Negative 2 times negative 7 is positive 14. Negative 9 plus 14 gives me 5. 5 times negative 2 is negative 10. Add, and I have a negative 10. Negative 2 times negative 10 gives me 20. Add, and I have a 20. Negative 2 times 20 gives me negative 40. And I add and get negative 28. So what's my answer? 1x to 1 less power than this right here would be x to the 6th. So x to the 6th minus 2x to the 5th plus 4x to the 4th minus 7x cubed plus 5x squared minus 10x plus 20 plus a negative 28 divided by, I don't have a lot of room for that, do I? Let's see if I can do a little better. Let's just drop down here, plus a negative 28 divided by our divisor of x plus 2. Now some people will say to me, I'd rather write that as minus positive 28 over x plus 2. And that is quite acceptable to do so. In a little bit, I might just show you why I recommend leaving it this way for most people.